I would like to thank again all the people who have been working, building and operating this instrument. As a user, I have been very, very happy to use it. Thank you again. And Bruno, is okay with you?
Yeah, that's fine. Thank you. So let me just add to this. I think the numbers that John has just presented us is a testimony to Sandro and his team who built this instrument and made it work for 20 years with so few problems in terms of maintenance and operational issues. So that's really a fantastic achievement, I should say that. I propose that we're actually quite over time, but I still would like to spend about half an hour for the discussion. We have another discussion session tomorrow, which is slightly longer. So I think we should start with a presentation that Amelia Bayo is going to give us. It turns out Lorenzo Monaco, who would be the second person to present something, he seems to be not well. And so Amelia has agreed that she will present all the slides. They had a presentation that's coupled together. And so we're going to listen to Amelia and then we'll take questions and discussions after that. So Amelia, please.
Hi everybody. Thank you, Bruno. Can you hear me well and can you see my slides in full screen?
Not yet.
Yes,
you have to hit the play button.
Okay, I did. So let me.
Okay, Amelia, this is Pages, not Pages, Keynote, yes?
Keynote. I go to full.
In Keynote, you can select presentation in a window.
True.
Normally, and then you share the window.
Yes, you're right. Sorry. That was in view. Well, if I share,
or if you share the entire desktop,
the full thing,
also be okay.
It should work also, right?
Yes,
yeah,
that's
okay.
working, yes.
Yeah, thank you very much. Sorry about that. Yeah, so I'm really sorry that Lorenzo is feeling not well. Well, because I don't want him to feel bad, but also because he did most of the work here. So I feel very much as an intruder presenting all the stuff because he did most of it. So yeah, I hope he gets well very soon. And this is just to set a bit the stage for the discussion. So basically, well, I want to thank the organizers also, of course, for inviting me to try to set this discussion up. And also, I really enjoyed the talks, besides waking up very early. But it was a really, really nice summary of an instrument that has been so robust in producing great science and in behaving super well. So if we remember from this morning, from the very first nice talk, the science goals for the instrument were to study chemical composition and atmosphere of stars, stellar winds, stellar rotation, magnetic fields, kinematics in the ISM, radial velocities. I'm going to focus more on the stellar part because if I feel an imposter in the stellar part, I don't want to even tell you how I feel if I talk about extragalactic stuff, and we will have another discussion tomorrow, so that's great. And what we did, Lorenzo and me, we just checked. We've seen similar stuff before during the day. So we check the top 10 papers on UVES using UVES and see how it relates to the science goals that set up the instrument, right? And as you can see, there is a great correlation. So clearly very, very popular papers. So these are the top 10 papers ordered by citations. So the really, really popular and extremely interesting paper by Hivchana on the multiplicity of massive stars. So RV having consistent, you don't need, for some science cases, you don't need to have ultra high precision in radial velocity, but with the kind of radial velocities that UVES give us, we can do a lot on studying binaries. And we can go to high mass in distant regions, and we can go to low mass at many different distances. And this is a paper of 2012, so it's not that young, but for example, and I cannot help advertising the job of the work of one of my students, Sebastián Zúñiga just had a paper on UVES data using the archive to prove that this idea that we have that all SBs, spectroscopic binaries, 10% of spectroscopic binaries is a universal thing, maybe that's not so true. So great work for binaries. Definitely a huge amount of knowledge has come out from studying the abundances, because the resolution is perfect and the wavelength range is perfect to all of these different trends of enrichment or not. And we had a great talk, mostly on Gaia ISO results, but where other points were touched also. So another check for the science goals. Then a lot of studies on metal poor stars, again because of the resolution, because of the large collecting area, and because of the wavelength range. So key points to have such a successful instrument that could fulfill the science goals: as I said, high resolution, radial velocity stability, blue coverage, wide wavelength coverage, and you can reach faint objects, right? Then we thought that maybe we could also show some maybe not so obvious uses of UVES. Maybe for some people they are obvious. They are super biased, I'm sorry, they are really biased towards my science and my interest. But I thought it was good to show this. So for example, by using spectroastrometry with UVES, we can study, we can look for putative and very controversial protoplanets in different objects, like here in Tica Maleontis, where having high angular resolution allows you to go to, high spectral resolution allows you to go to high angular resolution, and you can be probing the H-alpha environment of a transition disk, so looking for a protoplanet, as 3.65 milliards seconds from the star. Then maybe something else that it was not in the science goals of UVES is the study of proto-substellar objects. And here we have, when we think about proto-stars, proto-substellar objects, we're always thinking about mid-infrared, near-infrared, and UVES, Bas Maria showed with this UVES spectrum the amount of forbidden lines and super interesting lines that we can study on an extremely young, extremely low mass object. We're talking about a proto-brown dwarf that the central mass is supposed to be around 36 Jupiter masses. Then exotic objects that you can find also combining, and this is the power also of the archive of UVES. On the left, I'm showing this HR10, this main sequence binary that has two shells. So basically there are two objects with shells, and you can see those shells by subtracting your photosphere, and then you see these shells moving around, so you can trace these two objects. Extremely interesting. And we had a really nice talk about comets today, and with UVES we've been studying, and again, sorry for my bias, my students are present also here, so I feel very good that I can advertise the job. We can study comets on extrasolar systems. So basically here is the work of Daniela Iglesias. Using plenty of archival data, she can identify additional components on different lines, so calcium, for example, and cut some exocomets on these sources. So what makes UVES extremely useful? We've said it before, and we will say it again. Its solution is coverage. And then let's talk about the UV efficiency. And here, I'm sorry if I got something wrong, but if I understand correctly, when UVES came to place, it was beating HIRES, but then with the upgrades, that is not so much the case. But hopefully with the upgrade of UVES of the blue arm, it will, well, we heard an estimated improvement of 50%, so that's great, because really it has a very specific range where it is still, and with the upgrade it will be, the best use for the ultraviolet from the ground with a large aperture, with a large telescope. And that won't be, for example, beat at all by neither a shooter because of the cut in wavelength, nor Hughes because of the resolution. So there is still a lot of potential in that parameter space. Here I'm just going to the same point of the efficiency, and I think I'm running a bit late, so I'm going to try to go a bit faster. So as I mentioned here, an improvement on the sensitivity, on the efficiency of the blue arm will be key because still there are the 2 points where UVES has no competing instrument, which is the resolution at the blue wavelength range. So one scientific case that Lorenzo wanted to emphasize is, and that we have heard today, is that there are key elements that we can only access with high resolution in this wavelength range, right? So if we want to study these different enrichment mechanisms, then we need to have access to this wavelength range with this resolution. Also, we need to assess some of the other competing factors, like Espresso is a wonderful machine. There's a wonderful machine with a very specific goal also. It's a planet hunting machine, right? So it will require intensive use of the telescope. So having UVES, it also allows for some kind of balance between different scientific communities. There are here some of the science cases that I went through before. And we have heard about the upgrade of the blue arm. That is something that I think we all agree that would be great in keeping up with the really high publication record of UVES. And we just throw this idea. It may be totally crazy. I mean, it is totally crazy, but because there is this concept, for example, of using cryosplash with a sphere, right? A la gravity in a way. So you use the high angular resolution to resolve, for example, an exoplanet forming, again, my bias, sorry. And then you plug your fiber to get a high resolution spectra. And we are always talking about near infrared when we talk about these concepts. But what about the optical? I mean, we can learn so much from the optical. We know those who study substellar object formation, we know that H alpha is still a lot more useful because we don't understand so well bracket gamma and other lines. And we could have something maybe like PDS 70B or C at high resolution and understand much better the kinematics of the accretion processes of these planets in forming. And here I just want to leave these points that I think I try to combine what we had discussed before and what was discussed during the day, of points that maybe we should discuss as a community. So the discussion on how UVES is going to be is the follow-up machine for many different surveys. So how to do it in an optimal way. I want to emphasize so much the huge legacy value for the archive. Is so important for the operations that we have science-ready data that we can use to assess operations, but also for the community to have this stable, nice science-ready data to exploit. And also I want to highlight that UVES is a great instrument for filler programs. And we know that, bad weather conditions happen and we have to use them as well as possible. And UVES is extremely good performing in bad seeing and things like that. You can still have a large slit and do really nice science. So I just wanted to highlight that. And I'm sorry I went a bit too long.
Thank you, Amelia. Thank you very much. This is very good. As a co-I of a large program that did actually use UVES in bad seeing conditions for a couple of years, I very much support your last point. But I also would mention that Espresso, of course, is exactly the same way. It's available at any telescope, anytime, essentially. So we have one raised hand. At least I see one raised hand. That's Stefano Cristiani. Stefano, you want to say something?
No, it should not be raised.
Well, now it's gone away. Okay.
Sorry.
That's all right.
Where is it? Because I can't see it raised on my terminal. Sorry.
Right. It was up with me. So, yeah. So the discussion is open. Anybody who wants to raise something here, maybe just to clarify, because Luca and I and Robert and Antoine sit around quite a bit discussing various instruments for the VLT. Nobody ever said, this was sort of mentioned maybe a couple of times, nobody ever said that we would decommission UVES in any foreseeable time, okay? We had an evaluation, I did an evaluation of all the VLT instruments 3 years ago, and it came up that the two oldest instruments and the two most demanded instruments, FORCE and UVES, or UVES and FORCE, which would be the right order, had not been touched for 20 years. And so that was at the time, a statement that I made, that we need to think about these instruments to continue to operate for the foreseeable future, and that resulted in a force upgrade. And we're now discussing what to do with UVES. And so this is part of that discussion. So Luca, I think, had his hand up.
Yes, can you hear me?
Yeah.
Yeah. No, I think, of course, I'm biased because I've been an enormous fan of UVES from the very beginning. I did probably 80%, 90% of my scientific career on this instrument. So, plus now is my instrument in a way. So, accept that I'm heavily biased. But I think there is one thing that, looking at the career of UVES from actually before I realized much about it, I think there is one big lesson for me, at least. One of the things that Amelia was showing, the fact that there were so many things designed for, but that UVES did well. That to me tells that one big power of UVES is that UVES is designed as a workforce, as a workhorse. It's not designed as a highly specified, specialized instrument. So while a specialized instrument, of course, in my mind now there's espresso, will absolutely smoke UVES at what is made for. That's pretty obvious. Its lack of configurability, I think, is something that has to be considered in the equation of what we want to do with UVES. UVES is highly flexible, and do we want to lose this advantage? And if I can add a very quick second question, saying you can do this and you can do that with espresso is actually very true, but espresso has more than twice the pressure of UVES at the moment. The net result is that anything that is not in the really, how can I say, the native science for espresso will be heavily disadvantaged at the OPC level, and we will not be able to do these things with espresso because we will not get time to do these things with espresso unless the pressure on espresso lowers, which I don't think will happen. I mean, that is my doubt about this. Thank you.
Fine. But just to reiterate what I just said, nobody says that UVES will not operate for another 10 or 15, 20 years, okay?
Yeah.
The debate that we will have is, if there is an upgrade, what upgrade should it be? Now, if you say, well, UVES should have more UV sensitivity, then the answer will be, but cubes, we're building an extra instrument to have UV sensibility. Then you say, well, but the chemical abundances cannot be done with cubes. Well, it turns out the cube science case heavily is based on chemical abundances. So we need to find the exact parameters to put this all together. And that's part of the discussion that we're having here. So that's perfectly all right.
Yes.
It would be interesting to have other people join in and tell us what they think will be important.
I think Vanessa Hill wanted to.
I think Valentina was before me.
Sorry.
Okay.
Thank you. Actually, sorry, let me put the video on. So can you see me?
Yeah.
Okay, it was just a quick comment on one of the last slides from Amelia. Very nice presentation. It's about the connection of UVES to some optical, like an analogous to Sphere and Cryres Plus. So there was the idea until a few months ago to attach espresso to the visible channel of Sphere to do something similar, but then it was abandoned, I think, because I think the number of science cases and objects to which you can apply this kind of facility is very limited, because in the near infrared you have the bulk of photons from the exoplanets. So I'm not sure this will be something really efficient in terms of science return. And actually, another very quick comment on what was just mentioned on the combination and differences in sciences between cubes and UVES. I think it's true that cubes can do science for chemical abundances, but maybe that's especially true for relatively metal-poor stars, because as we know, when you go to the metal-rich regime, we cannot use a resolution of 20,000 to derive heavy elements or beryllium. Okay.
Okay, good. So Vanessa.
Yeah, I just wanted to first plus what Lucas Bordone was saying before. I think it's very important that in the upgrades we consider for UVES, we keep this idea of the workhorse, so of the variety of science cases that this instrument should be providing data for. And that's the first comment. And my second comment is that I think in Amelia's last slide, there was the question of the UVES fibers. So I'm going to come back to it. I mean, despite what you're saying, Bruno, what will happen is that the UVES fibers at some point will be decommissioned. So that's part of the instrument current UVES use that will disappear. And this is something we seriously consider. So I don't know if it's completely crazy to think of I don't know, blue optimized fibers to be still fed to UVES from some. I mean, I don't know what would be the right setup for the thinking of replacing this thing, because going back to also what John was showing before, I mean of course, the UVES slit is the most workhorse mode that is being used by UVES. But when you multiply by the actual multiplex, so the number of objects that are observed in a given exposure, I think that the UVES fibers is really not far behind.
Yeah. So you're referring to the flames fibers, I can't remember the
flames UVES.
Yes, and so flames is a whole other story. I understand. I haven't seen too much myself, but fixed it is not HR Moss, and this is something that I think ESA has very much on its radar, in the sense that we know this was a very strong science case that came up at the VLT 2030 workshop, and I think most people were convinced. We do have very good science cases in the UV that Chris Evans has been working out for cubes, and by translation can be used for general UV science, UV spectroscopy. So that's all happening, and I think we're all looking forward to these developments. The flames, same story. I mean, right now, nobody talks about taking flames off the telescope, but there's no need to do that right now. But it's also true that flames in itself is not competitive once foremost and moons and some of the other massive multi-object spectrographs at other facilities come online. And so in some sense, then the 16 fibers that go from flames to UVES become in themselves an interesting thing to look at. Just as a historic note, I don't know whether Sandra is still on, this was of course, or Hans, this was of course Alvio Rancini who pushed that into the system. When he brought this up, he said, we need to have these fibers. At least Hans, I remember, said, no way, we're not going to do this. And a couple of months later, he came back and says, this is how we're going to do it. So this afterthought is now becoming a science driver, which is great. I love it. So that's certainly something to look at. I agree. The optical fiber from a AO system like Sphere has been proposed at the VLT 2030 workshop as well. It was seen very quickly that we would not regard this as a facility instrument because the applicable science cases are very few. Okay, so at that time, people talked about one object that they could look at. And so if the community out there thinks there is a sign that they are really interested in this, they can come up with the funding and the resources. There is this option at ESO to do visiting instruments, but it would be probably an overkill to do that type of facility at the moment. You know, once the efficiencies go up, you know, I don't know, the fibers work better, then that's a different story. Here are not. Luca, did you put your hand up again? Or Amelia, you put up your hand. Sorry, Amelia.
No, I'm sorry. I just left there.
And Amazon has up.
And Amazon, yeah.
Okay. What? They don't show up. Okay, sorry.
Can you hear me?
Yes.
I just want to comment. First, I'm very happy that UVES won't be decommissioned anytime soon, and I hope I won't be decommissioned before I retire, at least. Because, and here I remark what Lucas said, Lucas Bordone, that its strength is the fact that it has is not a specific instrument. And in this sense is unique. It is not replaceable with cubes because of resolution, but most important, because of wavelength coverage. I think that is a pity that John Pritchard couldn't tell us how much was the use of the combined dichroic setup, because that would be an information on how often the whole optical range is needed to the science case. I think that maybe may still allow abundance analysis, but we rely on data already existing in the archive for covering the missing wavelength range. Instead, when one is working with variable or with transient, delayed setup, delayed instrument that they do not work simultaneously, of course, are not longer an option. Right. And that's it. And the other important thing is that it has a high resolution, but not so high as other instruments are proposing. And it's the only one, together with the X-shooter, that goes below to 3000 angstrom, which is a wavelength range which is very important when one works with photoionization, but also with hot source. Soon, HST will be decommissioned, which is another pity. And but the information that we have learned with UVES in combining the optical range with the high resolution in the UV range allow us to continue understanding what happens from 3000 to 10,000 angstrom. Using those wavelength range, we can understand what is happening in the UV once we have, like we did, combine the whole ultraviolet and optical range for hot sources, to say. And so I don't know whether there is a real need for an upgrade of UVES. Of course, if we are in position to increase the efficiency, that is always welcome. What I may have missed from the talk of this morning by Kosmaski is whether the upgrade is just a best wish or is actually already in place somehow, or already under study.
I don't know whether Luca wants to answer this.
No, sorry, we can ask. No, it's absolutely not a place. What Johan showed was a possible way, which would be, I mean, okay, let me put it in this way. we started from a perspective that anything which is an upgrade on UVES must be limited. I mean, we cannot think at this point of rebuild an instrument. We do not have the strength, the possibility, the money, and the people to do that. And so looking in this direction, knowing that the blue arm had, for instance, this vignetting, which is variable but can be very high, and the camera had suffered by losing the resolving power because of the earthquake and other situations in the past, this has been a way that we look at it, if you want, as a Gedanke experiment, something that also is easy in the sense that, well, you go, you apply to the table, you don't need to dismount the whole instrument and blah, blah. But it is not a proposal, it's not on the table. It is just an example of an interesting possibility. We would like to have, after this workshop, possibly a collection of some kind of requirements and a further discussion with INISO, with the STC and everybody on whether we should proceed even on an upgrade or just make a maintenance. I mean, nothing is written at present.
Thank you. Valentina. Okay, John, if you wanted to.
Just quickly address the issue that Elena raised. Statistics for dichroic mode. It's very difficult to calculate this, I think, for two reasons. One, I think the vast majority of programs use the dichroic mode, but the vast majority of those do not use both dichroics to get the entire spectral range. Most will use one setting within a dichroic mode. Yeah. So they obviously they're not requiring the entire spectral range. And then those programs that actually do, we have a very limited number that require those two observations to be taken contemporaneously, one after the other, for example. And those we could catch, I think. But the others that say, well, I just need dichroic 1 and dichroic 2 taken sometime during the period, it would be very difficult to catch them and evaluate their statistics apart from going manually through the proposals. And I just don't think we have the manpower to do that in any systematic or reliable way. So it's an extremely interesting question, but I don't know how to address it at this time.
Yeah. Thank you, John. I have Celine Peru raised her hand. Celine?
See if you can hear now.
We can, yes.
I wanted to add some of my experience on this very point that Elena and John have commented. I, with UVES, see little reason why not using the dichroic, right? So even if my top science goals are, set on one wavelength, the costs of using the dichroic is very little. So I think counting the number of observations with the dichroic is not exactly telling us, what's the need for the wide wavelength coverage, unfortunately. It's even, I think, another level up. Now, I have a more general question about, an upgrade and which upgrade, if any. My question is, do we have a sense of, because we all, are user of UVES, and we can we estimate the impact in terms of operation of one solution, one upgrade or another, in terms of how long the instrument is not available and what's the impact of its operation, right?
Right. So very good point. I was thinking whether I should raise it myself, and then I didn't. As long as we don't know what the upgrade is, it's impossible to say how long the instrument would be out of operations. How modular, for example, something could be done. It's too early, but it's something that I think is very important to factor in. If you say the upgrade takes 3 years to be extreme, okay, that means that the instrument would not be offered for 3 years to the community. And that needs to be understood before we do it. I completely agree with that. So that's Amelia, you wanted to say something?
Yeah, No, I think this is a really good point noted down. Yeah, how long will the instrument not be offered? That's definitely super important, and that's why I guess that's why also this kind of mental exercise has been done, right? Because this kind of upgrade was relatively easy, with many quotes, but relatively easy, or at least easier than some other things that we can think of. But I wanted to also voice a couple of things that were being told in the chat, because it's true that losses in fibers are super important, but it is also true that there is a lot of development, right? And there is a lot of integrated optics development. So, I think it's good to be realistic, but one can also not be too pessimistic. And the other point that was being made is that you're totally right, Bruno, that X-Shooter, you can offer it, you can ask for it in any UT at any time, so it's very flexible in that way. But the resolution can be too good, right? And that puts you a limiting magnitude. Somebody else, I think it was Luca, was pointing this out. So that's the thing. I think we have to say that they are really complementary. So that's the power of it, I think.
Sure, fully understood. I think we've run out of time. I don't want to drag this out any longer. Thank you, Amelia, for contributing to the discussion. Thank you, everybody, for listening in.